Mr. Townsend, do you ever get cold in your room?
Do I ever get cold?
Yes. It's always cold in here.
Well, the thermostat was broken last year. Not in third class.
What?
Not the first 10 minutes of class. So the thermostat was broken last year. I have not told them that it's broken yet because when they fix the heat, it'll mean the AC probably breaks. And this time of year, I think we'd rather be cold than hot. So,
How you service?
not during the first 10 minutes of class. You just have lunch to do all that.
Mr. Townsend, Ezra left.
I saw that.
Yeah.
I called him a quitter in the hallway today.
I'm trying to find my calculator right now. Hopefully I can find it. Yes.
Make sure you grab the handout on the front table up there if you didn't get it.
Should I just set this? Number 3?
Yes, that's
Okay. Josie wanted me to tell you hi.
Josie.
Cadets.
She could have told me herself.
She will.
Immigration quiz. So this is our first actual new content.
What? Integration quiz is upcoming.
Oh, I know. No. I was talking about the integration by parts.
No one? Wait, can I say yes?
No. Okay, first off, I need y'all to turn in number 3. So look in your binder, make sure your name is on that, and come throw that up here, please. And I also need you to get out number 4 from last class. Hey, Roya, come sit at this desk. He switched to the other period. Can you slide down 3 desks?
What?
This desk right here is now open.
No, she can sit there, but not me.
I don't want anyone in that desk if possible. It's too far at an angle. You're fine. Plus you need to be here where I can keep tabs on you. Just number 3. Okay, any other assignment 3s to be turned in?
I like your shoes.
Thank you. All right, so we need to continue on with number 4. I know you guys worked on some of that already. Thank you. And I will grade these and get them back to you today. Okay, but what I'd like to do is make sure that you guys got the correct answers to the ones I asked you to do on number 4. Make sure that you have a chance to ask me to go over any of those that you need me to. And then we're going to talk about some of the others. A couple of these are a little bit less important. But question 1, you should have done 1A. 1A was the U substitution question. And I ended up with this as an answer. So if you did not get that as an answer for 1A, put that answer out to the side. Try to figure out what mistake you made in a few minutes, and if you need me to go over it, I would be happy to do so. But that's what I got for number 1A. 2A was the U sub for number 2. That one I ended up with 1/2 natural log absolute value x squared plus 5 plus c. You guys okay with that one? Okay, this is a little bit kind of sidebar, but it's good to think about. If I made up this question on a test, I would remove the absolute value signs before I put the answer down. Free response, it doesn't matter. But why is it okay for me to remove these absolute values this time?
It's always possible.
Right, x squared plus 5 is always positive, so you don't really have to keep these absolute value signs if you're sure that the stuff under is positive. Okay, number 3, which one of these two was U sub? B, I agree. I got 1/2 natural log absolute value x squared plus 4x plus 5, all plus c. Same thing. You didn't get that, jot the right answer out to the side, and make sure that you ask for help sometime today. Number 4, which one of these two did U sub? B was correct. I felt like this one was a little bit harder, or it just felt a little bit less familiar, but that's what I came up with as an answer. Don't forget, you can always check your answers to these if you're willing to take the derivative. If you take the derivative of that and remember chain rule and simplify your answer, you should go back to what you started with. All right, number 5, which one was U sub?
B.
Agree. 1/54 3x squared minus 1 to the 9th plus c. And number 6, which one was U sub? A. I also agree there. 1/3 natural log absolute value x cubed plus 1 plus c. Okay, so before we go on, because as I mentioned, U sub's going to be important in a couple classes, not today, but is there any of those 6 that you were supposed to do for homework that you need help with, that you want me to go over? Any of them that you thought were harder than the rest?
Can you go over number 2?
Number 2A, right?
Yeah, just getting that step from like to get to the natural log.
Okay, so I would pick U to be this, so your du should be that. So this is 1/2 1 over U du. Is that what it looked like when you did that?
Well, I have U to the -1, but
Oh, same thing. Okay, so sure, U to the -1. Now, if you tried to undo power rule here, you're going to discover why we need to memorize this natural log rule. Because if you try to undo power rule, you raise the power by 1 and divide by the new power, but you can't divide by 0. So that's where undoing the power rule doesn't make sense there. 1 over x or 1 over u is going to integrate as natural log of x or natural log of u. That's just one you want to memorize. So. Okay, any of the others? Okay, then let's keep going. So I know some of you did more than that, and that's fine. But again, I really wanted you to put some thought into when U substitution works versus when it doesn't work. So let's go back to 1B, and I'm going to follow y'all's direction here. But how could we go about doing 1B if it's not U substitution? We only have a couple integration tools. Okay, so do some algebra first. Just distribute, expand all of this stuff. So maybe square this. That would mean multiply it by itself. Make sure you don't just square this and square this. You actually have to FOIL it. You could distribute the x, and it's going to look like this. So notice I haven't done any calculus yet. I just did some algebra, just did some distributing. Why is this easier to integrate than this?
There's nothing to it like in parentheses with the square around it.
Okay. So how would I integrate x to the 7th?
X to the 8th.
Okay, so just undo power rule. Then you can do the second term separately. Undo power rule. Raise the power by 1. Divide by the new power. Do the third term separately. Raise the power by 1. Divide by the new power. Remember, you can always check these with derivatives. And don't forget your plus c. So if you multiply all that out, I guess the question's harder algebraically, but then it makes the integration much simpler. You need to copy this one down unless you took it upon yourself to work ahead. Everybody okay with that? So, algebra if you can, before the calculus. Okay, 2b is a pretty tough one. We're going to come back to that one. I would not expect anyone or many people to figure that one out. But 3b was the unit circle question. U substitution question. So 3a is not. So it's not U substitution, and I can't just distribute like I could in 1b. So if, I don't know if Ms. Cross showed you guys this. In my class, I showed this to you like 2 questions on notes, but then you didn't have to use it at all the whole year. Does anybody have any guess on how we can make this stuff look different? Any math thing we could do to make that look different? Okay. How does that help?
So you get x plus 2 squared
Okay.
and plus 1.
Could you factor out the top?
Okay, you could, what you're talking about is something called completing the square. But you need to be careful. I don't think that this x plus 2 squared that you're going to get here can't cancel out this x plus 2 because you've got another factor over here. So that wouldn't, you'd get stuck doing that. Yeah.
Could you factor the top and then split into 2 fractions?
You can, the top doesn't factor. Yeah.
Could you like complete the square and then 1 plus parentheses x plus 2 squared and then split it?
Maybe.
Like,
I have no idea.
Long division.
Long division, thank you. If you do long division, which we need to be able to do anyway, I'm not going to focus on long division too much here, but just remember that I want you to see how this could be helpful. It's not something you need to go to right away, but just know it's a tool. X times x is what gives you x squared. X times 2 is what gives you 2x. Make sure you subtract these two. The next part of your answer would be 2, because 2 times x is what gives you 2x. Make sure you subtract these. So, long division says that if I divide this by this, it's the same as the quotient, x plus 2, plus the remainder over the divisor. And can we integrate this? This should be easy now. That should be the hard part. Undo power rule. Undo power rule. And then this fits the natural log stuff that we memorize. And the only thing that I forgot for my answer is what? Plus C. So long division is not a common technique, but we do need it occasionally. So if we need to slow down and talk about how to do the long division again, we can, but for right now we're not going to worry about it. Long division rewrites it in a way that made different terms easy to integrate. Okay, on to, let's get 4a for just a second as well. I really didn't even mean to get into that on day 2, but that's okay. Look at 5a. So you should have already figured out it's not U substitution. It's obviously not one you have memorized. It's one of the other things we've tried this morning or this afternoon. What could we do? Right. Multiply this stuff together. This is just like 1b. Square this Make sure you don't just square the 3x and square the 1. You actually have to FOIL it out. Go out to the side if you need to, so that you don't lose where this minus 6x is coming from. Distribute the x. And then you've got 3 terms to integrate. But we can do terms individually. So, raise the power by 1, divide by the new power. Raise the power by 1, divide by the new power. Raise the power by 1, divide by the new power. Don't forget your plus c. Now, obviously, I know you can all FOIL. I know you can all distribute. The challenge here is recognizing, hey, I need to do that if something else isn't working. Or even if you thought you knew how to do that, distributing before integrating is still pretty easy. So, okay, anything else you want to ask about 5a? Okay, one more, and then we'll go back to the other two so that those are there. Now, I'm looking for something different on this question. I'm not looking for U substitution, obviously. I'm not looking for distributing. I think you probably could do long division if you wanted to, but what else could we do on this question? Very good, separate. So just like distributing is an algebra thing that makes your calculus question easier, you need to make sure that you know you can split apart fractions as well. You can put this part of the numerator over the denominator, as long as you put this part of the numerator over the denominator. You cannot split apart denominators, you can split apart numerators. But this simplifies. You might rewrite this one this way, and then just I do power rule twice. Raise the power by 1, divide by the new power, check with derivative. Raise the power by 1, divide by the new power, check by taking the derivative. Don't forget your plus c. Anytime you can do algebra, fraction work, exponent work before the calculus, you probably want to. So whether that's distributing, splitting apart your fractions, whatever. Easier than U substitution, or it should be. Okay. Everybody okay with that one too? Okay, the other two you are not on the hook for yet. I want to go ahead and show them to you, and I want you to have them in your notes here, but I will warn you and ask you to do more practice on this before I throw it at you on an assessment. So 2b is a great question. You start going through your list of things, and you realize that no integration you've learned allows you to do this question. Doesn't look like anything I've memorized. I'm not just undoing the power rule. I can't do U substitution. I can't really split apart this fraction. I can't just distribute. Everything else we've tried in the other questions just is not working out. So there is a technique, a math technique that I don't know that many of you guys have heard of. It came up a minute ago. It is called completing the square. You've heard of completing the square at least? Does anyone remember how to complete the square? No? Okay, what we're going to do is we're going to add a number here, a very specific number, so that this factors as a perfect square. So that this stuff factors as a perfect square. What? Eventually, but not yet. Okay, so that you don't have to guess this, most students memorize how to find this number that you're supposed to magically add. It's half of b squared. When I say b, I'm talking about the coefficient of x, like quadratic formula. So b is, half of that is, and square it, you get, so 4 for this question is the magic number that's going to make this work. So I'm going to put down plus 4. Now, if I just write down plus 4, I'm changing the question. So I'm going to write down plus 4 and a minus 4. That way those balance out. So I'm going to combine these two to say plus 1. And then this is, if you use this number, this is going to factor perfectly. This is what times what?
2 times x plus 2.
X plus 2.
Okay, x plus 2 times x plus 2 is a perfect square. All right, now this just totally depends on if you remember this type of integration. Now this looks like one that we have memorized. It is inverse tangent. Very good. Inverse tangent is the one that looks like this. Or I can switch these. So instead of an x, they have a u, but if you can see that it's in the same pattern, your answer would be inverse tangent of what's being plugged in, x plus 2 plus c. So completing the square is actually not that hard. You're just adding a number to make it square nicely and then subtracting the number to make sure that you don't change the question. Sometimes you have to do that to make it look a certain way. So again, even though you're not on the hook here, please emphasize your notes this way. I put a plus 4 or minus 4 here, and that plus 4 minus 4 came from this. Half of b squared. Half of b squared tells you the magic number that makes it factor into a perfect square. Okay, and then we've got to do the same thing for the last one. Number 4a is a similar question type. This one I will start off with the inverse trig that you would have to have memorized. And if you were in my class, I told you that you did need to memorize this before your AP exam, but it's not one you had to use a lot. Inverse tangent and inverse sine are the two that show up on our AP exams a lot. This one will integrate the derivative of inverse sine is 1 over the square root of 1 minus x squared. If we're not worried about chain rule here. So if we are worried about chain rule, let's just change this to a u and this to a u. Same difference. So the only way you'd be able to do this one is have this memorized, which again, I will warn you before I expect you to do that on a quiz. Have this memorized, and then with some work, we can make this one look like this one. So the first step or two, it's not going to get us too much progress. I'm going to suggest to you that you put these in descending order. And just one other suggestion is maybe factor out the negative. And I left a little bit of space there because I know I'm going to complete the square here to make it look like this. Okay, so this magic number that we need to complete the square, how do I go about finding that? What's the formula? Okay, b over 2 squared. What do you think b is in this question? Okay, so half of 4 would be 2. Square 2, you get 4. So you can put a plus 4 there. The reason I want to put a plus 4 there is now this factors as x plus 2 times x plus 2, or x plus 2 squared. Now I can see something subtract something squared. Subtract something squared. Okay, what about this? I wrote down plus 4 here. Should I put plus 4 there?
Plus 4 minus.
Oh wait, why minus 4? Or plus 4?
Oh, be some minus.
Yeah, it was minus 4.
Right, so notice I physically on my paper wrote down plus 4, but do you see how that's being multiplied by a negative? So me physically writing plus 4 here actually subtracted 4 from the question, so I need to add 4 to keep it balanced. You need to make sure that whatever you write down times all of this stuff gets balanced out. I'm doing this in a different color to help you see this. Now, I can combine these two to say plus 1, which is perfect. That's what I needed. And if I switch these two terms in the denominator now, Now, do you see how this looks like the derivative of inverse sine? Can you see how these two match up? Okay, so what's our final answer to this question?
Sine. Inverse sine
Okay, inverse sine of what?
of,
What are we plugging in?
X plus 2
X plus 2? Is that it?
plus C.
Plus C? Yeah, what you got, Suman?
When you factor out the negative, shouldn't that have been x squared minus 4x?
Yes, it should be. This should be minus,
Yeah.
so this should be minus. Thank you. And this should be minus. And this should be minus. Good catch. You guys see how these two match up? U is just x minus 2. This is the same thing as this, but instead of u, they put in an x minus 2. So those are pretty tough questions. That's why I didn't want you to worry about those until you'd practice the others. You had to remember this, which we will have to rememorize this year. The derivative of inverse sine and inverse tangent at the bare minimum, because those two show up on the AP exam line. And then someday we'll have to practice more of this, completing the square. But completing the square just adds a special number so it factors as a perfect square, and then you can make it look a certain way. Okay, so I will probably pick that one up next class, so you need to put that away in your binder so that you can find it. Now, so obviously I realize we need lots of practice on U substitution, which is why I put that aside for us. But we need to start looking at some new calculus as well. We need to start moving that direction. So now I'm going to show you some integration problems that other stuff just doesn't work on. No completing the square, no long division, nothing that you just memorized, nothing that's going to work with just U substitution. We need a new strategy to work different type of integration problems. So for the notes here, basically what it amounts to is kind of a weird way to write it, but we can fill it in for our notes. If you have something divided by something, we are going to take some time and rewrite it like this, where we have some number over some x's plus a constant plus another number, probably a different number, over a number of x's plus a constant. You could have a third one plus dot 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 all the way to the last one. So on the last one, I'm going to say a sub n. What do you think n means? A what?
like any number.
Right, just a generic number, whatever you're going to. So 1, 2, 3, all the way up to n. A sub n x plus b sub n. Okay, so that tells us basically nothing, but we're going to rewrite it like that. Okay, so here's what we're going to do. I'm going to go over the first couple of these with you and then have you practice some of the other ones, but I want to integrate this. And again, you can spend as much time on that with the techniques that you currently know, and it's just not going to work out for you. But if we know some algebra, we are going to make this look different, just like all the other techniques. And if we do it the right way, it's going to be very easy to integrate at the end. So I'm going to take this big rational function, this big fraction, and I'm going to change its format. I want to figure out this is the same thing as what over x minus 1 plus what over x plus 2. I'm going to use the same factors that that one has. Okay, now I'm going to multiply everything by x minus 1. That's going to make this denominator and this denominator go away. And I'm going to multiply everything by x plus 2, which is going to make this denominator and this denominator go away. So when I multiply everything by x minus 1, x plus 2, it will look like this. Is everybody okay with that? With why the fractions disappear like that? Okay. Next up, we are going to try to solve for a and b here. So a and b are just constants, so they should always be the same value no matter what x value you're looking at. So we're going to say when x equals -2, I'm picking a number that makes this go to 0. If I plug in -2 in for x here, I get 1 equals, this is going to go to 0, and this is going to go to -3b. So by plugging in -2 for x, I can tell you that b is -1/3. Okay, and now I'm going to temporarily plug in a different number for x. What number do you think I will plug in this time? Okay, let's plug in 1 up here. So everywhere there's an x, I'm going to plug in a 1, and that's going to give me 3a equals 0. Plugging in 1 into this goes to 0. Oh, sorry, 1 is equal to 3a. So therefore, a is 1/3. So I've just figured out the big fraction they want me to integrate, I can split it up into two smaller fractions this way. Some number over x minus 1 plus a different number over x plus 2. So take their question, and we're going to say that's the same as integrating a over x minus 1 plus integrating b over x plus 2. And usually with constants, we just pull the constant out front. So that's the same thing as this. I want to pull this constant out as well. And now finally I have to do one step of calculus to get the answer. I can integrate this guy with the stuff we have memorized. Can integrate this guy with the stuff we have memorized. And so this is an indefinite integral. We need a plus c. There's your answer. So 99% of these question types is the algebra steps over there. Making sure you know the process. I know you can do the process. You just have to practice the process enough that you can work through it without being told. So let's go through that one more time with question 2, and then I'll let you try question 3. It's going to be a very similar idea. Okay, I want to come up with this, and U substitution doesn't work, nothing else works. So we can try this thing called partial fractions. So if I factor this, and then factor it completely, this one's got 3 terms. So the thing that they are wanting me to integrate is 2x squared minus 7 over x times x plus 1 times x minus 4. I'm going to change the way that looks with algebra so that I'm not trying to integrate one big fraction, and instead I'm going to integrate 3 small fractions. What do you think the denominator of the 3 fractions are going to be? Very good. The factors of the problem that you had. Okay, and then above x we'll put a, b, and then c. So if we can figure out the numbers for a, b, and c, integrating this scary looking thing is going to be the same as integrating these 3 smaller things, which are going to be significantly easier to do. So we need to solve for a, b, and c. So I'm going to take this big equation, I'm going to multiply everything by x, which is going to make some of the denominators go away. I'm going to multiply everything by x plus 1 to make more of the denominators go away. And then I'm going to multiply everything by x minus 4 to make the last of the denominators go away. So if I multiply this by all three, all of its denominators go away. If I multiply this by all three, the x's cancel out and leaves behind an x plus 1 and an x minus 4. When I multiply this b fraction by all three of those factors, I get an x and an x minus 4. The x plus 1 would cancel out his denominator. And then c, what would be multiplied by c?
X and X plus 1.
Very good. All three of them except the x minus 4. His x minus 4 is canceling out his denominator. So, again, I've still got a scary looking equation here, and I need to solve for three different variables, a, b, and c. But a, b, and c should be the same all the time, no matter what x value you're looking at. So let's just pick a number for x. When x equals what? What do you want to pick? Okay, I heard 4. So if we plug in 4 into this, I would get 32 minus 7, which is 25, equals, what does all of this go to? 0, because if this goes to 0, 0 times anything is 0. This also goes to 0, and this goes to c times 4 times 5, so 20c. So notice it's not so bad after all. C ends up being 5/4. Now we just need to do this 2 more times for a and b, plug them back in, and then actually do the integration. So somebody else tell me what's a number other than 4 we should probably plug in. Okay, I heard -1. So that could be 2 minus 7, which would be -5. This would go to 0. That goes to 0, and plugging in -1 here would be -b times -5, so 5b, and therefore I know b is -1. All right, and then Addison, can you tell me the last one?
0.
Very good, 0. Plug 0 into this mess, you end up with this statement. This goes to 0, this goes to 0, so you're just left with a times 1 times -4. So it looks like a is 7/4. Again, I know I'm going over that kind of quickly, but you're going to be comfortable with those steps after you practice it a few times. Again, I've not done a single bit of calculus at this point, other than realizing I shouldn't take a different approach. I have just figured out a way to take this question that they started with, and I'm going to rewrite it. I'm going to integrate what I got for a over x, a over x, plus b over x plus 1, and I'm just pulling the constants out front. Here's my b over x plus 1, plus c over x minus 4. So here is my c over x minus 4. Again, my a, b, and c were all in the numerator. I just pulled them out front because they were all constants. Now, you should need about 5 more seconds. This integrates as 7/4 natural log absolute value of x. This integrates as negative natural log of absolute value of x plus 1. And this integrates as plus 5/4 natural log absolute value of x minus 4. And we need plus c. So all of that is your answer. Obviously. I'm sure y'all could just see that answer just from starting that question, right? You just knew the answer was going to look like that. So it is pretty scary looking, but again, 99% of your practice needs to be algebra practice. So that's where it should get easier with some practice. Okay, turn the page over. Go ahead and try question 1. I'm going to step out of the way this time, so I will go over another one of these with you on the board. It'll be number 1, but I want everyone to at least try it now instead of me just telling you what to do. So. In fact, I will even throw the answer up here real quick so that if you get that, you can just keep chugging along. Okay. That answer is up on the board if you need it. I don't remember that one being so hard. Maybe you had an arithmetic mistake. It didn't look worse to me than the others.
Just made like together.
We might just come back to it later. Do the others first. everybody either finished or stuck with number 1? Okay. If you did not get this as an answer for number 1, you should follow along with me. If you did, you can just keep on going because you don't need help. So, I factored this denominator into x times x minus 4. And then I tried to figure out when does x minus 12 over x times x minus 4 be the same thing as some number over x plus some number over x minus 4. If I can solve for a and b, then instead of integrating this, I can integrate this, which is a lot easier. That's the idea behind making it look that way. So I'm going to multiply everything by x, multiply everything by x minus 4. That gets rid of all the fraction work. And that should leave you a statement that looks like this. So temporarily plug in a number like x equals 0. And you would get that as a statement, which gives you 3 for a. You could temporarily plug in 4. I'm looking at stuff that makes one of these go away. Plugging in 0 made this go away. Now I need to plug in 4 to make that go away. So plugging in 4 gives me negative 8 equals 4b. So b is negative 2. Now I'm going to rewrite this. I'm going to integrate a over x plus b over x minus 4. And again, it's really just my preference, but I like to put the constant out front. So integrate this guy to get 3 natural log absolute value of x. Integrate that guy to get minus 2 natural log absolute value of x minus 4. And you need your plus c because of the type of integration it is. Okay, so 2 things about this one. First off, make sure that if you made a mistake, fix it on your paper, but also make sure you understand why, and better yet, write yourself a little note there, because whatever mistake you made is probably going to come up on other questions. And then 2, even if you got this question right, I need to make sure that you know that this could look different as a multiple choice question, because can't we condense logarithms of the same type? If we have logarithms of the same type, subtraction would condense into what? Division. So you'd have to pull the 3 back up as an exponent, pull the 2 back up as an exponent, but you could also write this like this. Subtraction between 2 natural logs you could condense into a division of natural logs. You just have to know to pull the 3 and the 2 up out of the way. Just make sure that you could do that if you had to. Okay, anybody that had trouble with number 1 have something specific about it while it's up there? Okay, then I'm going to share my answers for the next 3, 2, 3, and 4. I'll put them all down here. And then that should give you some quick checks to make sure you're not completely off track here. And I'll share my answers without any condensing or anything, just in case that's what's throwing you off. So 2 can look like that. Number 3 should look like that. It's like a whole sentence for an answer here. And there's number 4. So as you finish those, if you got something different, notice I didn't condense, but if you got something different, first try to find your mistake, and then second, make sure you get help if you can't find it. So I'm going to finish grading these homeworks so I can get them back to you. So you guys are welcome to to work together and help each other. I am going to ask that you try all of these between now and Monday. So if you can try all of these in class, then I guess you don't have any homework. But if there's some of them you don't get to in class, I'd like you to try those before I see you again. I suspect that you might want help on a couple, and that's okay, but you need to have tried them all. It's okay, I figured it out. Also, I put it in the grade book. I don't know why that's not so. Barely read yours too. Did you?
Yes.
How do you say that?
Sheen.
Sheen?
Probation. Yeah.
Sheen?
Yes.
Okay. You'll have to tell me if you can. Did Thompson tell you I was calling him?
Yes,
I mean,
he
yeah,
did.
I'll
Or
call-
Tommy or whatever.
I'm gonna call him a different keyword.
He doesn't know Henry.
Henry?
Yeah, he gets called Henry a lot.
Oh.
I like the
Well, he wasn't in class today, so.
Oh.
Oh, got it.
They left at 7. Texas. Tennessee.
I think I get think I called it turnip or trombone on the.
I'm just doing monkey see, monkey do, and it's working. That's all I'm doing.
Oh, he better. I'm gonna know if he did.
That's true.
Like, I'm just like seeing like what he did, and I'm just like doing that and everything, and I'm getting it.
Yeah, it's just the process.
Yes.
Honestly, like, again, it takes some practice for you to feel comfortable doing the process without looking at examples. But this isn't the hardest thing y'all have ever had to do.
Can I go on?
No, yeah, keep going.
Okay.
I just want to make sure you're on the right track. If you're doing something wrong, I want you to know early so that we can figure it out. I don't want you to keep just reinforcing the wrong thing. Vincent. Jessica. My wife's name is Jessica.
Mr. Johnson,
Andrew.
why did you do this knowing slide this year?
Just feeling lazy.
Have you updated your Brawl Stars?
My first period class, I have had everyone in there as a student at some point except for 4 of them.
Really?
I never got to see her get to know me, so because I had you second semester. I hear you're big into Rocket League though.
How many hours?
I haven't even played Rocket League in months.
Did you Rocket League and is it Dota 2?
Oh yeah, you're a big Dota.
I haven't played Dota in years though. That game's too addictive. To be careful. No, so what I figured out is the years that I do like stuff about me the first day, people don't remember it after a few months anyway, so.
I remember that you have no sick days.
Okay, what kind of dog do I have? What's my dog's name?
Well, it's not as interesting.
I remember you get up at like 4.
Wait, are you gonna tell us your days of grades?
I've already told them to you before. That's my point.
Not this year though, it's been a whole year.
The answers are still the same.
Okay, I forgot them. You put a lot of math in my brain since then. I don't have room for the dogs.
I only remember the video games.
My dog's name is Motor.
Oh yeah, what kind of dog is it?
He's a pound puppy, mostly pit bull.
Oh.
That's about it. I play video games.
I remember that stuff from sophomore year, but I don't remember anything else.
I remember talking about video games a lot when I was in here for advisory time sometimes.
I remember yelling at y'all to stop talking about video games while we were doing calculus.
Luke was playing like Doom on his DS. I remember Luke played Doom on his DS. He hacked
Oh,
his,
right, yeah.
He hacked his DS.
I saw Luke this summer. I went to go get my oil change down at Grease Pig, and he came in like right after me. He lost a lug nut or something. So.
May I use the restroom now?
Yeah, as long as it's not the first or last 10 minutes, you don't have to ask.
Do I have to write something?
Yeah, your name,
Oh.
and then take your name off when you bring your pass back. That way, if you lose the pass, I know who to blame.
Okay.
They don't.
First and last.
I prefer like first and last. I don't know him, so. Okay, is anybody still working on 2, 3, or 4? I can come over and help you come up to those answers.
You should check your 5.
Did you condense it or not?
Number 5?
Yeah.
Oh no.
Okay, so negative natural log absolute value of x plus natural log absolute value of x minus 2 plus c.
Okay. Should I condense? Is that
As long as you know how to.
okay?
You would have to bring up that one negative on the x,
Yeah.
and then you could condense with multiplication. So, I don't know. I've seen some AP questions where you have to condense to figure out which answer it is. after the calculus, so I don't know how common it is. It's not bad to practice.
He's there. Good.
You get number 6?
I'm not sure if it's right though.
For sure. I did number 6 wrong, so. How did you know to do this first?
Intuition.
See, I didn't do that. I just went to this.
Oh.
And I got all of this part right, but I didn't get that part.
Oh.
I gotta figure out why you have to do long division first. Sometime between now and Monday. Yeah, y'all can do. Y'all are welcome. If you think one of these questions is U substitution, they're not. But if you think they're U substitution, go for it. Like, you don't have to do this process if you think you can do something else.
Wait,
Try
did
it.
you do number 6 again?
Yeah.
Yeah.
Number 6, you should do long division, yes.
Do you have to? Can you get the answer to that number?
No. You can get part of the answer, but you need part of the answer.
Wow.
That I don't know. I don't know how you're supposed to know that you have to do long division on that first. I gotta figure that out. That looks good.
I haven't changed my sheets.
I need to change the airplane. I have allergy.
This doesn't integrate like that.
Yeah, I'm allergic to a lot of stuff in here. So it's like,
I'm allergic to most
It's
trees.
gonna, because it changes the floor one second. Or just do my substitution.
All the trees.
I'm allergic to like generic pollen. I don't know what pollen is.
I went in and took like a full-on allergy test at an allergy clinic.
I haven't done that since like kindergarten.
Well, I didn't evaluate for your allergic, so
I'm allergic to
it's just saying between 0 and 50.
these 4.
That's
Allergy
allergy.
shots, but
What you're trying to do. Not that there's any way to do it.
I was never going to do that.
So it's
shots
not
like
like
no,
you're at a plus.
surprisingly.
I didn't care enough.
Okay. Is there any of this past stuff holding you back that you don't remember?
No, all of this is good as long as soon as I remembered how to derive things, I was fine doing the last part too. So
Okay.
we're all good.
That's why you said
Did you ever make this?
it's the same as I'm.
Wait, what? Does anyone know how to do it?
1/50th natural log of P.
No, yeah.
You didn't integrate that.
Got that.
Minus 1/50th natural log of 50 minus P. Plus the 2. That's what I got.
So like the boundaries, we don't.
Yeah, you don't need bounds for 7. They're just saying that's what the anti-derivative is. They're not to evaluate.
No way.
Well, that's what I was doing.
If I take the derivative of this, you're gonna get, what is that this? You're gonna get 1 over this times -1. So you have to, so if you had done U substitution there, you would have caught that, but if you're skipping U substitution, you just have to be careful.
Ask them if that's the right answer. He says,
Yeah, I need that for part of it. Okay,
Mine makes sense.
Yeah, I think so.
Nice.
where'd
You
you
can condense it and everything too.
X, Y, and negative. So that's too.
You know, that's 7 times too big. You gotta look back at that one. Yeah, that's good. That's what I get. Got a couple of look back at.
We're on 6. What? Did we get 6 right?
Oh, sorry.
You were asking me if you
Yeah,
got
you
it
got
right?
NBC.
Oh.
Yeah. Wait, did I have this? Wait.
That part's right.
That's
But there's another piece here. This is what I was telling them. You gotta do long division on this question first, and if you do long division, you get those two parts of the answer. But I don't know what about this you're supposed to know, how you're supposed to know to do long division first on this one about that. I don't have an answer for you on that yet.
Oh shit. So you just gotta do long division.
Yeah.
Well, if you do long division, you get a couple terms out here that you can integrate easily. And then when you do the rest of this, it gives you the same thing, that's what you just got without doing long division. So, we'll talk about it more on Monday, because I need to figure out how you're supposed to know when to do long division or not. That part looks fine, but again, but I was just telling them, for some reason, this one you have to do long division first, because you lose this part of your answer without doing that. And I don't have a good answer for you right now. So just put a star by that one. We'll need to update it, but for today it's fine.
Can you explain where?
Do long division, this divided into this is equal to your quotient plus your remainder
Yeah, I know.
over your divisor. So the thing you were dividing by.
So over
This part.
Yeah.
This is your quotient
right?
plus your remainder, only your remainder over your divisor. Your divisor is all of
So x plus two
plus.
it's not all over. Over
That's the
this.
denominator.
Over the
That's the
denominator.
you're dividing by.
There's bounds and you
So these two are easy to integrate. But for this, you've got to go through that process.
Okay, so then you're gonna have.
You guys do the
For the
long
next
division.
part for this thing, is it a over x plus two and then also this?
These are fine. You know how to integrate this term, you know how to integrate this term, so don't worry about those. Yeah, now you're
And then that comes back.
So it just gets there.
But again, I don't know why we have to start with long division on that question, so.
Okay.
And I'll go through the.
I wonder if your summer did you have to spend learning this stuff or learning how to teach it?
I didn't spend too long.
Wait, did you
I did
finish all
most
of
of the
it?
first couple weeks,
Did you get them
and
all?
then I do a 5-day workshop. Every 5 years, we have a 5-day training.
Did you get
So
that?
I would do that.
Oh, that's not too bad.
But the training I had signed up for was 8 weeks, because I didn't know that they were gonna make
Did you get 6 or what?
They just couldn't believe anybody could put out bills without doing it.
Okay.
Yeah, I agree. You do it the remainder and the.
Okay, so when you take this divided into this, that's the same thing as your quotient, x plus 2, plus the remainder over the divisor.
Okay, so, and then what do you do with all of that?
So all of this is the same thing as x plus 2 plus x plus 1 over this.
Okay, so you just do that instead of this.
Well, so the x plus 2 is gonna be easy to integrate. You know how to integrate x.
Yeah.
You know how to integrate 2.
Yeah.
The rest is gonna come by doing the partial fractions, like we did on this one.
Okay.
I did it separately because I just
Nice.
That's okay, just give it a shot. Erase your 7.
No, you don't have to keep it like that. If you want to like simplify this, you can bring 4 up, so that'll be ln 9 to the 4th.
Yeah.
And then you can do
Divided by 4
ln
though.
and then 4. Yep. 9 to the 4th over ln. That's one way you can simplify it. But you can't just subtract it.
A was 4, yeah, when you do the same thing, it's just gonna multiply by 4, so it's already there.
So you can leave it, just leave it like this. Because you can put that into the calculator and then number of this is just leave it. So don't do anything for it, otherwise you're gonna get it wrong. I didn't even do this stuff. I was like,
So you did, so it's kind of like this one.
Too hard?
No, I don't think so. And then what do you do? Oh.
Wait till we get the series.
I thought 3C is supposed to be easy.
It is, I think it's easy.
I've seen my sister study on series. It's a lot.
Series is pretty good. Did you take AD here last year? Ms. Ross?
Well, there's a one for.
AD is just faster. There's a lot more stuff in AD, so you just have to move quicker.
Oh, wait,
You
you're
gotta not, you gotta move on. In VC, there's like 4 techniques like this. You already learned one of them. And then there's 2 more, there's 2 units.
I'm at 8. I don't really want to do anymore.
Normal, difficult.
I kind of don't want. What did you get for 7?
I didn't, there's just not much new for you to learn this year. This just happens to be one of them.
I get the stuff, but the thing is I gotta memorize the process.
Well, don't memorize the process, think about why it works.
The process is
I've always had trouble with
that
that
difficult.
kind of stuff in math.
It's okay. You can leave it like that.
The process seems
There it
pretty
is.
complicated.
I've got answers here. What number are you at? 9 and 10.
It doesn't matter.
I can move all the way down here. Olivia also had a number of 7 here. Do you know, did you figure out why your 7 was in that question?
I just do terrible.
Wait, where's your Excel though?
I didn't.
Okay, so this 4,
Yeah.
you either need to do U substitution or double check your integration with your. And are you okay with how I condensed those 2?
Do I play golf?
Yeah.
Not every day,
Real
most
freak
days.
out, so.
It's on Julie.
Is that an 8?
Yes.
Or I should.
But then we have to hold it all together.
So let me hide this. If you have 2 of the same type of logs separated by addition, how do those get condensed?
I condensed those 2. That one reads 2. And then I added
We got second last.
Okay,
position.
okay. So there's another way to say this though.
Oh.
You can bring the 3 up.
Okay.
Each person,
Yeah.
and you take their scores.
But if it's still the same answer, like, do you need to condense it?
You don't, sometimes you need to, but wait, that's not the same though. Why do you got a 5 over there?
Did you also get a 5?
No, it would help if I'm looking at the right question.
What do you think?
Okay. Is that the only 2 you need to look at? The rest of them? No.
That is.
It's just telling you that.
Wait, so there wouldn't be a 4 there because the lower
Here's my
Total
baseball.
value of that function.
Wait, so because
Oh, yeah.
well, then I got being
I used to. Yeah. Not anymore though.
Okay.
I think I got 1 on both of them earlier. Look at my answers first.
Yeah, but you only want 1, so you divided by 2.
Okay, it's this.
Okay, so that.
Yeah.
Okay, I'll leave it.
So it'd be L and 9.
Natural log of x on which is natural log absolute.
Yeah.
Plus 26 natural log absolute.
Yeah, A and B, I got 150.
Yeah.
Okay.
So
For
you know how there's a
150.
4 there? There's something called chain rules.
I'm on that.
There's a 4. So if you take the derivative of 4x plus 1, it's not 1, right? It would be 4. And so
Look at all this space you've got.
since the derivative is 4, you've got to divide by 4. Because normally in chain rule, you would multiply by 4. So you got to divide by 4 and a row.
indefinite, it's definite. So you have to use a balance.
see, cause like all I did was just, I just plugged in numbers.
Right here.
Yeah.
So it's just yeah.
Your A is
Which is just
4, right?
L1.
My A is, yeah.
You know,
I don't see your mistakes. Let me grab mine.
Okay, I got still this 8.
Okay, I was just saying it's still.
What?
Or the 11. Negative 11 plus 8 is negative.
2 values, x plus 4 minus.
Yeah.
Okay, from 0 to 2. So you plug in 2, you get that. Plug in that, you get that. Okay. Oh, I know what the problem is.
There's just one.
I think it was. Did you just leave it?
I just want to have it here.
Okay.
So you just divide
And then you divide it over this, right?
That's the whole problem.
So it is right.
It is right. My brain doesn't memorize this.
When you subtract, remember when you subtract, you divide. Since it doesn't subtract, you divide, you just pull out the element. You don't subtract, you have to divide.
You integrate that.
9 divided by 6.
So like you have the in.
And so if it's like this, 9 over 3, you can make it
So
like 9 minus
you can integrate this. So when I integrate this, 4 over do all this or just this?
4 over 4x plus 1.
With wow integrated. Yeah. So that's integrated.
So what did you give for mine?
Did you actually figure it out?
It's 4 over x plus 1. I can show you.
So if you integrate this and you say, I'm going to carry this 4 down, and you get 1 over 4x plus 1, you get a natural log of 4x plus 1.
Yeah, x.
The problem with this is, this has chain rule.
Yeah.
You see
It's
how this
just
is
the
going
top
to create
part
a
is the
4 already? So you need to multiply by a 4th, which makes that one go away. Okay. So you can either do U substitution there, and U substitution will take care of that for you, or as soon as you write down that anti-derivative, check it. How's advisory been?
He used to have the secretary for Mondays.
Yeah, who's your advisory
She's sleeping.
Are you in there with anybody else?
Why is that so high?
I know Jack and Jack are not here.
What did you do?
What? Or English?
Just
Advisor switch.
No, so I think, and no one has told me this, but I think what they do is they take the number of ninth graders divided by the number of ninth grade advisors, and then they figure out the number that's got weight, so that's usually like 22. Okay?
Yeah, but
So then the first advisor gets 22, the next advisor gets 22, the next advisor gets 22. Then the last advisor gets the leftover, so not 22, just how the remainder. So 2 years ago, I had the remainder, so we had the smallest, like, what did you do? So then because it's a small group, the next year, they're desperate for more ninth grade advisors, so they made those 13 students break into other advisors. And then I got into ninth grade. And then ninth grade, last year I had another small group, so they made them split up again, and I have ninth grade advisor again. But I get, but the trade-off is I have smaller groups. I don't have as big as advisors. I don't mind. And ninth graders, they just believe in green and color. They don't. That's my favorite.
Put that in. Subtracted by the second.
This doesn't matter.
Well, I mean, I tell them all the good school stuff and get them, you know, do your homework, blah, blah, blah. And, but I try to throw like one rule at them that's not a real rule and see if I can get them to do it all the time.
I'd probably.
Check some? Well, what's the natural log of 1? Okay, so all that goes away. These get this is in the most common mistake right here. This doesn't integrate in that when you add. Think about it, if you put the derivative of this. You would get 1 over 4x plus 1 times 4. So to balance it out, you need to multiply by 4, which makes that 4 disappear. So either you have to do U substitution so that you don't do that, or you need to double check your integration by taking it. So just erase that 4, and then the only other thing is change it. So you can leave it like this, or you can screw it. And then this one, yeah, I didn't want to finish it, but I got to go back. This is fine, but again, this will use my zero, so. Do you want to check in a few?
I just ordered mine.
That's what Trish
That's one of the most common problems. Right here. If I take a derivative of what you have here, you get 1 over 4x plus 1, then this stuff. Minus 12, I can do that. And if I do times 4, then you can have the 4, then that makes it 16. It's not supposed to be 1. So you need to multiply by 4, which makes that 1 look like it. Yeah, basically, you can fix it by just erasing the 4, but you need to understand why. If I take the derivative of this, that, and you want that, so you must multiply by 4. Cancels out the other 4 that you have. You'll never make that mistake that you did U substitution here, but short of doing U substitution, make yourself take the derivative of this. If
there's anything other than just one positive, that you also use U substitution.
Or you can just undo the chain rule by multiplying by 4. That's easier to me, but if that's too much to keep up with, then you can do U substitution, and U substitution is a process that will work. I think it's like
Does anything change for the definite?
well, a definite gonna have you're gonna have to plug in the 1 and plug the 0 and subtract them at the end. You don't get to say plus C.
Oh, yeah.
See, like here, instead of saying plus C, you had to plug in 1 into all of this, and then plug in 0 into all of this, and it's a plus. That's the fundamental thing of calculus.
Right. I should have, yeah. Still getting in the groove a little bit.
You guys are all together.
If you're in this class, you
This my last name. It's not. It's not. Then I don't know. I don't know.
I mean, it'd be good to.
Probably should try one more and do
Yeah.
20.
So you're a junior. So you'll come in February to school.
Do I hate you? Hate's a strong word.
Or do you dislike me?
No. Why would I dislike you?
I don't know. I just have the vibes.
Because I'm about to tell you to sit down?
Yeah, that means you dislike me.
I know, how terrible of me.
You put me up there, like by the, because I'm all alone right now.
She's so sharp.
You're right by me. It's the best seat.
That's true. I should be more grateful.
My super scores.
You'll be this is the second day of school. You guys will have plenty of time.
Yeah,
Yeah. I've been studying. I need to start studying. What's your
Okay, so 2 things. I need to remind you what the homework is. Try all of the questions on number 5, so at the very least you know which ones you need help with on Monday. Write that down if you need to. I guess it's also on the agenda if you want to pull up the class website. 2, I've got a puzzle for you. This one is going to be timed though, and no cheating. No looking it up online. Okay, if you want to participate in this puzzle, the only way I know to do fair to figure out if somebody wins is you have to write your answer down on paper. It can be on this, it's fine, just put it on the bottom, but you have to have it written down, and you're going to have to hold it up when I tell you time is up. I'm only going to give you a limited amount of time. Because with an infinite amount of time, you should all be able to get it right. Are you ready? So you can keep working on it. If you have homework, you're welcome to keep going on with that. You don't have to do this. But we'll see if anyone can get that.
Oh no.
Just write it down if you have an answer. Just put it on your paper. The closest one wins. Wait, why are y'all helping each other? You can't win.
Do we get money if we get it? No?
You got money to donate to the prize?
I have like 1 penny.
Okay. Well, then it sounds like the
Oh my God.
prize is 1 penny.
I see it.
Oh, wait, Javed, you know the answer, right?
That's a large number. Somewhere like 200.
Simple math.
The reason why I'm giving you limited time on this one is because you could just physically count them up if you had time. So it's kind of best guess, or if you figure out a pattern, you can do it quicker with math. But I'm only going to give you about 2 more minutes.
I think I got it.
Write it down on your paper. Did anybody watch the video on the clock that I sent to the Google Classroom?
Oh, you did one?
We didn't need to, we already understood it.
You didn't know how to find the answers to the second part.
Oh, yeah, that's true.
I put them back in the math closet.
Sorry, I'm trying.
No, you're fine.
I was gonna make your little one.
Are we allowed to use a calculator?
You don't need to.
I don't want to add up all of it.
You don't have to.
Because you could choose that one, that one, that one.
You know what? No, I give
No,
up.
it's
I should probably do what's wrong anyways.
It's simple math. The answer should be unless it's the stupid
Okay, so how many there were? Wait, you can do like
I'm gonna bank on it now.
Yeah, it's like
I'm gonna bank on that.
That would be the first class, that would be it.
Okay, if you have an answer, hold your piece of paper up. Or calculator. Or note card.
That's
How
why I
many
always,
people? How many people are trying here?
that's why I always carry that.
I mean, if people's asking for squares,
Well, squares can.
Okay, keep your. You have to keep your answer held up until I tell you more information. What is your guess? 784. 110.
100.
100. 144.
88.
88.
204.
204.
Simply 64.
64. 104.
204.
204. 2 people got it right.
Was it 2? What was it? What was it?
Answer is 204.
I got it!
It's the stupid
You!
triangle. The
You
squares
got
make
204.
squares and the squares squares.
Yeah.
Yeah.
There's 64 in the 8 times 8 is 64, so you should have gotten the individual one. Yeah, but then this is another one.
Yeah.
This is one. You guys were looking at those too, right?
Yeah.
Yeah.
Okay.
Okay,
I know.
okay.
204.
Yeah.
Wow. 64 plus 49 plus 25. This is a pattern.
You figured out the pattern?
Can I see the answer there?
Yours is 204. I didn't read that. I
Check to see if I can.
This or condensed. Right here, natural log of 1 is. Right, so all that goes away here. The rest looks pretty close. Alright, so what was your guess?
Oh, we did right.
Oh, yeah. You can.
Is it just the 1 square plus 2 square equals a square?
I don't know. I only know the answer because I looked it up.
Yeah, okay, yeah. Natural log of a fraction can just be the denominator, right? The natural log of a fraction can just be the denominator, right?
The natural log of a fraction would just be the
Right, I think I goofed some up. Yeah, I goofed some up.
Okay.
Sorry, I didn't keep.
We'll look at it on Monday.
Yeah, man, dang it. Sometimes I forget.